Good morning, ladies and gentlemen. This is Mr. Rowe. We're taking a look at intermediate algebra here. This is lesson 2. This is part of scientific notation. This is a concept that should have kind of, you've gone over several times in middle school. So let's go through the concept just so everybody understands exactly where you need to be with this. So first of all, let's take a look at what is scientific notation. Well, scientific notation is just a way to write numbers differently. It's usually reserved for either extremely large numbers or extremely small numbers. So numbers like this can be converted to scientific notation, and numbers like this are converted to scientific notation. To have a number that is proper scientific notation, it has two parts. The first part is a decimal. And what's important about the decimal, it has to be between 1 and 10. It can't be 10, but it goes right up to 10. So it's a decimal between 1 and 10 times 10 to a power. And that power is where you get all of this stuff from. And we'll talk about that as we go through the rest of it. But you got to have two parts. A decimal, 1 or bigger, but less than 10, times a power of 10 with an exponent. So let's take a look at some examples here. We're going to start off with some extremely large numbers. And we're going to first write in scientific notation, and then we're going to show you how to write it back in standard form. So here is our first example. So let's take a look at this one. We'll make it a little bit bigger so I have some space here. All right, I'm going to do the same thing with this one while I'm working. Move it over. All right, so now, how do I turn 325 billion into scientific notation? Well, for scientific notation, remember I said the first part has to be a number between 1 and 10. So that number has to be between 1 and 10, and then 10 to a power. So those are the two blanks I'm trying to fill in here. So let's watch it how we fill these in. So the decimal on any number, unless you see it, starts at the end of the number. And so we're going to move that in between the first two significant digits. We're going to move it right between the 2 and the 3, the 3 and the 2. So what's my decimal part? My decimal part will be 3.25. Now, how do I get the exponent? I'm going to count all of the spaces that the number moved, the decimal moved. So it moved 3, 6, 9, 10, 11 spaces. So that'll be 3.25 times 10 to the 11th power. That's how you turn a number into scientific notation. Each step to the right, you're going to add 1. That's the exponent. So let's look at the second number. Again, we got two things we got to fill in. So there's my two blanks. That's what I'm trying to do. The first part, remember the decimal starts at the end. We're going to move it in between the first two significant digits. So it'll be 1.7. And then I'm going to count 1, 2, 3, 4, 5, 6, 7 spaces. So my number in scientific notation would be 1.7 times 10 to the 7th power. That's all there is to it. How do I go back the opposite direction? Well, I'm going to take this part and write it down. And now to get my number in scientific notation, I'll move the decimal to the left for a large number. So to turn it back, I'm going to move it that many spaces that direction. So 5 spaces to the right. 1, 2, 3, 4, 5. And what do I put in those blanks? I add some zeros. So this will be 500 or 425,000. Okay, same thing here. I'm going to write that 8.9 down. I'm moving my decimal 7 spaces that direction. And so, if I think about this logically, I've got 7 spaces to move. That's 1. So how many spaces or how many zeros should I add? I should add 6 zeros. 1, 2, 3, 4, 5, 6. So my number in scientific notation looks like that, 89 million. So that's extremely large numbers. Let's take a look at extremely small numbers. These are decimals. So we're going to do basically the same thing we just talked about. We're just moving the opposite direction. And then because we're moving the opposite direction, we're going to end up with negative exponents for these. All right, so again, moving the decimal between the first 2 significant digits. So right there. So that's going to be 7.5 for my decimal. And then because I'm moving it this way, that's going to be a negative value. And I'm going to count 1, 2, 3, 4, 5 spaces. So that'd be to the negative 5th power. That's all there is to this, folks. Same thing here. Move the decimal in between the first 2 significant digits. So that'll be 8.701. Yes, you need to write all of those down. How many spaces did it move? 1, 2, 3, 4, 5, 6, 7. So it would be times 10 to the negative 7. So that's it. And how you move these back to standard form? Well, this tells you how many spaces, and because we move it to the right when we turn it into scientific notation for these, we're going to move it the opposite direction. So negatives move to the left, positives will move to the right when you go back to standard form. So 8.21, move the space, 1, 2, 3. That's where the decimal goes. So we'll add our zeros. So that would be 0, 0, 8, 2, 1. That's it. And this is negative. So I'm going to write 2.38 down. This is 6, that direction. So that's 1. So how many zeros do I need to add? I need to add 5. 1, 2, 3, 4, 5. That's where the decimal goes. And then this will be a negative value. And that's in standard form. So I hope this helps you with converting to scientific notation and standard form. This is part of Intermediate Algebra Part B. This is Lesson 2. So if you still need help with this, please let me know in the teacher message or make an appointment for a help session.